This is the second interstellar object coming at us in 2 years. And from what astronomers are saying, we're going to have a lot more coming in at us. But where did this thing come from? Interstellar Comet 2I Borisov, that was found early August by an amateur Crimean astronomer who built his own telescope, by the way. And we'll do another thing on that, how big it is and how beautiful it was, because he found this thing. This is by Sergio Prostak on Sci News. So this new study by astronomers from Mickiewicz University of Space Research Center of Polish Academy of Sciences say that, well, they believe that the interstellar comet 2I Borisov most probably came from a binary star system called Kruger 60. Kruger 60 is a visual binary stellar system and is located in the constellation of Cepheus, Cepheus, also known as Dio Cephi, HD 239960, Gliese 860, BD 562783, we've heard of Gliese before, and ADS 15972. It's the 10th closest multiple stellar system and only 13.15 light years from the Sun, and it's approaching us. Kruger 60 is named after the German astronomer Adalbert Kruger, who discovered it. He observed it in 1873. It consists of two M-type stars. They're red dwarfs, Kruger 60A and Kruger 60B, and they orbit each other every 44.6 years. Kruger 60A has about 27% of the Sun's mass and 35% of the solar radius, and Kruger 60B is a smaller star with about 18% of the Sun's mass. So they're a binary system, as you can see, red dwarfs. Dr. Piotr Dybzinski from Astronomical Observatory Institute to the Mickiewicz University and colleagues found that Kruger 60 is a good candidate for the home system of 2I Interstellar Comet Borisov, a comet of interstellar origin. As we said, it was discovered, it says here August 30th, but I think it was the beginning of August anyway. The astronomers analyzed 548 observations of the interstellar comet available from the Minor Planet Center at the International Astronomical Union. They modeled the motion of this comet, the Sun, and 647 stellar systems from their list of potential perturbers of cometary motion. And they found that 1 million years ago, interstellar comet Borisov passed Kruger 60 at a distance of 5.7 light years, having an extremely small relative velocity of 7,700 miles an hour. And as the orbit of this comet will become more precise, the minimal distance between these two bodies might vary, but their relative velocity will remain very small, suggesting that interstellar comet Borisov might originate from Kruger 60. That's what the researchers are saying. And their paper was posted to ARXIV September 24th. And others are saying, according to European Space Agency, that Borisov, interstellar interloper Borisov, looks like a regular comet, for now that is. The first look at the chemical composition of this new interstellar comet reveals ingredients that look a lot like those found in solar system comets, and it's not likely to last very long, they said. This is by Nola Taylor Red, and I'll leave links below for you for these articles. The newest known visitor, the interstellar comet, and we will have more of them from what the astronomers are telling us. At the beginning of September, astronomers believed that the newly discovered comet Borisov originated outside our solar system. It's interstellar, and it's the second known interstellar comet. Borisov looks more like a comet than its predecessor Huma, Informally known, Huma appeared more like a lump of rock. Astronomers are beginning to probe the new interstellar visitor, the composition of it, and are finding is surprising like what we find in our solar system. They said it looks just like another random comet belonging to our sun. This is what Alan Fitzsimmons, commentary scientist at Queen's University Belfast, says. He led an international team to use the William Herschel telescope in the Canary Islands in Spain, studying the cyanogen gas in Borisov. The cyanogen gas, a molecule of carbon and nitrogen gas bound together. Cyanogen is one of the first things studied in comets orbiting the sun, and in part because it's so easy to spot this. The prevalence of cyanogen gas in our solar system did not mean that its presence in Borisov was a sure thing. Fitzsimmons said this is an object from another solar system. And although in almost every single comet we've ever studied closely enough in the solar system, we've seen cyanogen gas, cyanide gas that is, there was no guarantee it would be in this new Borisov interstellar object. And there it was there. Fitzsimmons cautions that these results are preliminary, and he said that other teams of astronomers are already probing for different types of gases in this new interstellar object. Scientists learn more about the chemistry of Borisov. Fitzsimmons expects that it will look less and less like our friendly neighborhood comet. He said, I would really be shocked if months down the line we did not find something significantly different between Borisov and solar system comets. Karen Meach, cometary astronomer who was part of Fitzsimmons' team, as well as other teams that discovered the Huma, agrees that we would not have any reason to believe that the exact same chemical mixture should be identical from one solar system to the other. She says if it is telling us about some fundamental process in planetary evolution that is the same everywhere. Now, this new paper will be published at Astrophysical Journal Letters and is available on the preprint server ARXIV. Now, the planetary leftovers. Throughout our galaxy, gravity pulls clouds of gas and dust together to make the stars, as we know, and the leftover debris around a newborn star may form a disk that can birth planets. After a few tens of millions of years, the eye blink in astronomical terms, that is, some of the dust and rocks get thrown about, crashing into newly formed planets, tossing into the star, hurling from the system completely. So being left over from planetary formation is the simplest explanation for interplanetary comet Borisov. According to Sean Raymond, he models planets formation for the Université de Bordeaux in France, and according to Raymond, most of the stuff hurled out of a young planetary system is icy, because icy things tend to form further out, where the star's gravity has a weaker home. Giant planets are also expected to form further from the stars, and they are often the most culpable when it comes to tossing out the younger comets. Raymond said we expect most of those things floating out there in interstellar space should be kind of like comets. Now, although the asteroid like Huma left astronomers scratching their heads because they only saw it as it was leaving, Borisov looks more like what astronomers have expected to spot since they began hunting for interstellar objects visiting us decades ago. But Borisov has its own surprises. This object is just too bright, Robert Jadik said. He's a comet researcher at the University of Hawaii. Jadik uses his knowledge of how asteroid surveys find asteroids to calculate how often astronomers should be able to discover new interstellar objects. He said this object is just too bright. Because astronomers had not found any interstellar objects prior to Huma in roughly 10 years and a half of observations, the astronomers expect that Huma would be They expected Huma would have been the last one seen for a few years. But not so. We're lucky enough to have a second one in 2 years. Borisov shining even brighter than expected. It's the brightest around the week of Christmas, they say, and the extraterrestrial comet should shine only slightly dimmer than Pluto. It's still too faint for most amateurs to spot, but the high-end telescopes sported by some enthusiasts could catch it. That's already been demonstrated because a visitor was discovered by an amateur astronomer, Gennady Borisov. He was using a homemade 0.65 meter telescope. This is like winning the lottery the first time we ever played it, Jedek said. For every interstellar interloper is as bright as Borisov, he estimates there should be many, many fainter objects, but other than Huma, none has been discovered, and Jedek is confident that they have not been overlooked. This object, he says, is either a complete fluke or it's telling us something fundamental about the behavior of these kinds of objects. He said that exactly what that might be will take some time to learn and will probably require overusing or observing more interstellar objects, obviously. Now, Borisov sheds a bulk of material in a cometary flare, the flare of the comet. It could grow even brighter than expected, allowing astronomers the opportunity to search for even more hard-to-find chemical constituents. Even without a flare, the comet will remain in sight for almost a year, so they'll be able to have tremendous observation of it, although it will be visible only from the southern hemisphere after December. Astronomers will have far more time to study this than the scant 2 weeks they had to observe and study Huma. Fitzsimmons said, "We're only just beginning to explore this new population of objects. It's the birth of a new field of scientific investigation." If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.